Alrighty, hello and good evening. Welcome to Chem 100 Lab Section 60. We are live tonight with Lab Activity 1. So hopefully you've got the pre-lab done, and we can begin work on Lab Activity 1. Again, so we're new to this kind of format. But I am live here and on Discord. Right now I'm in the Lab Activity 1 text channel. But hit me with your questions. You can ask them here in the live chat or in Discord. I will have my eye on both, be able to see and respond to both. And yeah, let me know as you run into snags, have questions. I am here to help you out. Lauren, that is correct. Oops. Correct. So you can find the download of the in-lab assignment under Lab Activity 1. There it goes. Okay. Just got it to download. It is a significant figures worksheet, which hopefully at this point you've made it through the significant figure lectures. Again, if you have any questions whatsoever, totally hit me up. I'm here. We've got the Photoshop open. The Photoshop. I sound like I'm from the old country. Oh, let's see here. Question 2C. since we have to move the decimal over 3 times. Okay, here, let me pull it up real quick. All right. Okay, yes. Okay, so question 2C. Which we have to for this question, we have to write in scientific notation. And the number we're given is 3,100.0 times 10 to the squared meters, and they ask us to write this in scientific notation. Now, with scientific notation, just by way of quick review, you write your number as a power of 10, and you always place the decimal immediately after the first non-decimal place. Here, hang on one sec. Okay, so we need to move the decimal behind our first non-zero digit. And that's going to require us to roll our decimal place over 1, 2, 3 spaces. So in scientific notation, this will be 3.1. Now there's 2 tricks to this. This isn't my final answer. First trick, since we move this decimal place over 1, 2, 3 spaces, we need to add 3 to our power of 10. So this is going to be times 10 to the 5th. But there's 2 additional things you have to be aware of. Anytime you're writing a number in scientific notation, if that number had units, you have to include the units in your answer, so this is meters. The second thing you have to watch out for is significant digits. Your answer, when you write a number in scientific notation, it needs to have the same number of significant digits that it had before we changed the number to scientific notation. So 3.1 times 10 to the 5th is the correct value, but we need to make sure it has the same number of significant digits. And if you look at 3,100.0 times 10 to the second. Now for significant digits, you do not count the times 10 to the second. That will not add any significant digits to the number. We count every non-zero digit, so 3 and 1 are significant. If you have a 0 that is both to the right of the decimal and at the end of the number, that 0 is significant. So this 0 is a significant figure because it's to the right of the decimal and at the end of the number. And then if you have any 0 that's in between significant digits, like these are, they are also significant. So this number, our starting number, has 5 Sig Figs, and 3.1 only has 2. So to write the correct answer with the correct value and the correct number of Sig Figs, we need to add 3 zeros so that we have 5 Sig Figs in our final answer. So 3,100.0 times 10 to the squared second, written in meters, written in scientific notation, is 3.1000 times 10 to the 5th meters. Okay, let's see. So question in the chat. So for all scientific notation problems, we include units after the... Yes. That is 100% correct. Evelia. Hopefully I said that correct. Yeah, you always, anytime you're given a number that has units, you gotta include those units as the answer. Because without units, your answer is actually meaningless. I was talking to my my daughter. I have a stepdaughter who's in 8th grade, and she's like learning about, you know, she's doing 8th grade science and units and all that stuff, and without units a number's meaningless, because if something is 13 in length, if it's inches, feet, or miles, those are 3 drastically different things, so we always include units. Okay, so let's see, 2a. Okay, let me Lorena, let me check that. 2a. Yep, times. Okay, so real quick. All right, I'm going to hit these all, but I'll hit these in sequential order. So, for example, (2a) is, so we got to write this in scientific notation. It's 34.27 centimeters. So again, we need our decimal place here. We got to scoot it over 1, 2, 3 spaces. So this is going to be 3.427 times 10 to the third centimeters. And again, you got to keep your units in play, and then you have to check your Sig Figs. And 3,427 has 4 non-zero digits, so 4 significant digits, and 3.427 also has 4. So this is your correct answer. Lorena, I think you put times 10 to the 4th when it's 10 to the 3rd. All right, Giovanni, let's see. Can you write down a separate sheet of paper? Photo, upload it. So Giovanni, if you're going to physically like write out your answers on paper, it can't be just on any piece of paper. You have to print out the worksheet from Canvas. You can fill that out and then use a scanning app like Adobe Scan, which is free, to create a PDF to upload. Okay, question from Discord. Will I go over the correct answers at the end of lab? Which is a great question. So the question was, will I be going over the correct answers at the end of lab? I can't do it this lab. I can totally discuss correct answers for any question you might have about this lab. I can do that next week. The reason why I can't do it at the end of lab is because the Thursday lab section still has their lab section. So if I gave you guys all the correct answers, then everybody in Thursday would get perfect scores. So I can, and like you can see, I've been doing problems. It's not like I can't show any, but I'm not going to give specific complete answers to every question before the other lab has the opportunity to do their assignment. Okay, so let's see. Karen's asking about. Okay. Let's. Oh wait. Let's see. Okay, let's see. So I see the Discord questions, which I'll get to in just one second. Karen in the YouTube comments has a something that's worth going over. So if you take a look at writing this number in scientific notation. All right, so again, we're looking for the first non-zero digit, which is 1. We're going to put the decimal there. Our current decimal is located right here, and we got to move it over 1, 2, 3. So notice what happens. We have to add 3 to our exponent of 10, and negative 3 plus 3 equals 0. And 10 to the 0 is just equal to 1. So this, in scientific notation, will just be 1 times 10 to the 0, or I will also accept just 1 as a correct answer. So you don't have to stress over that situation. But we still have to ask about Sig Figs. The number 1,000 times 10 to the negative 3 only has one significant digit, so our answer can only have one significant digit. So this answer will not have, any decimal places because we start with one sig fig. Therefore, we must end with one sig fig. Okay, question coming in from Discord. If I don't have a printer, is it okay if I digitally complete this thing? Absolutely. You can totally digitally modify the PDF and submit it that way. That's actually probably less work. So you can totally download it, type in your answers, upload it. You can, if you have an iPad or some sort of stylus device with your computer, like, where am I? Like I do. I have a Wacom. Intuos, not a Cintiq. Those things are amazing, but I can't afford them. You can write it out with a stylus. You can even like draw your answers with using a mouse if you want to. So you can totally modify it digitally and submit it. You do not have to print it out. The reason why I was talking about printing is someone asked if it's okay if they wrote their answers on a piece of paper, and if you are going to do it physically, it's got to be on a printout of the actual PDF. But digital modification, totally solid. Okay, let's see. So we have a question about 6C. Let's take a look at that guy. All right. Perform each calculation and report. Okay, this is good. Okay, here's the deal. So I am not going to do exactly 6C, but I'm going to do a similar problem to 6 part C, so you can see how to kind of break this problem down. So this problem is basically asking us to evaluate. And we need to express our answer in scientific notation. So let's do just that. Let's do 3.37 times 10 to the 16th times 2.54 times 10 to the negative 7th. All right, let's evaluate this and write our answer in scientific notation. Now, first off, one thing you'll notice is the only operation we have here is multiplication. This is multiplied, multiplied, and right here, though it's not written, when you have two parentheses next to each other, that means multiplied. So this is the same thing as 3.37 times 10 to the 16th times 2.54 times 10 to the negative 7th. And we know that multiplication, it doesn't matter what order you multiply in. You can do it in any order you want. So what I'm going to do is I'm going to regroup these. I'm going to place our exponents of 10 together, and I'm going to place our numbers together. Well, they're all numbers, but you know what I mean. So I'm going to do this in two steps. I'm going to evaluate 3.37 times 2.54, and then I'm going to multiply that by 10 to the 16th times 10 to the negative 7th. All right, so let's check it out. I'm going to bust out a calculator, which is my trusty phone. So I've got 3.37 times 2.54. All right, now the value here is 8.5598. But I gotta apply the rules for Sig Figs. I always have to apply the rules for significant figures. Even this problem explicitly specifies in scientific notation with the correct number of Sig Figs. And one thing you'll notice, 3.37 has 3 significant figures, 2.54 has 3 significant figures, so my answer can only have 3 Sig Figs. 9 rounds up. So this comes down to be 8.56 because it rounds that 5 up to a 6. All right. Now, times, we still have this 10 to the 16th times 10 to the 7th. Well, when you multiply powers of 10, that means you need to add these numbers. So 10 to the 16th times 10 to the negative 7th is 10 to the 16 minus 7. When you subtract 16 from 7, you get 9. So this is times 10 to the 9th. So our final answer then is 8.56 times 10 to the 9th. And that is an example that is similar to question 6, part C. I changed the numbers, but it's the same style of problem. We have a positive exponent, a negative exponent, and multiplication all the way through. All right, let's see. Could we do a brief... Okay, Gabriella. Oh, and Lexini. Okay. Could we do a brief explanation of the difference between positive and negative exponents in the scientific notation? I am blanking. Absolutely. We can totally... Absolutely. Okay. So let's do... Let's do a... exponent review. All right, so when you, oh, here, hang on, sorry. Real quick, I just saw a question that I missed. Okay, so here's how exponents of 10 work. Every place value in a number represents one power of 10. So, in other words, moving two spaces, I should say moving the decimal two spaces would be 10 squared. Moving the decimal four spaces would be 10 to the fourth, right? So however many spaces you move the decimal, that's how many powers of 10. Every one space is one power of 10. All right, so that's the first thing. Every place value represents one power of 10. Now, moving the decimal to the left makes the exponent positive. And moving the decimal in the opposite direction to the right makes the decimal, or makes the exponent, excuse me, negative. So if you're bumping your decimal to the right, that's going to be a negative exponent. If you're bumping your decimal to the left, that is going to be a positive exponent. And these are the three things that you need to be able to nail scientific notation. Let's put it into practice. All right, so let's write each of these in scientific notation, starting with 45 inches. Scientific notation, so our decimal is right here, right? We've got to move it so that it's behind the first non-zero digit. That's how you write something in scientific notation. So to write this in scientific notation, we've got to bump it one space to the left. So we're going to write this number as 4.5. And if you moved it one space, so this is going to be times 10 to the 1. And because we moved it to the right, that is exponent is going to be a positive value. So in scientific notation, this would be 4.5 times 10 to the first inches. Let's do another example. Let's write 0.1 foot in scientific notation. Now, scientific notation says that you need to place your decimal after the first non-zero digit. So here, we need to take our decimal and roll it over one space to the right. When you move your decimal to the right, well, first, so this will be 1. We don't put 0.0 because there's only one sig fig. Times 10. Now we moved it one space, so we know it's going to be 1 here, but since we moved it to the right, it's going to be negative 1. So this will be 1 times 10 to the negative 1 foot. Again, you moved it one space, so that exponent is 1. When you move it to the left, it's a positive exponent. When you move it to the right, it's a negative exponent. So now let's tackle let's write this in scientific notation. You find your first non-zero digit and know that you need to stick the decimal after the first non-zero digit. So we need to roll this 1, 2, 3 spaces over. So it's going to be 4. Oh, let me give it some units to work with here. We'll say 0.0048 liters. So this would be 4.8, right? Times 10. Now we moved it 3 spaces over, so we know it's going to be 10 to the third, and we moved it to the right, so it's 10 to the negative third liters. Does that make sense? Dude, awesome. Totally let me know. Totally let me know if you need more examples or need anything else explained. I am 100% here for it. Let's see, on number 5A on the worksheets. Oh, let's see. Let me take a look at number 3, 4. Calculate the following quantities and report the answer to the correct sig figs. Yeah, so with problem 5, A, B, C, and D, you have to evaluate the correct answer. So you have to do the multiplication, addition, subtraction, whatever they have for you, and then your answer needs to be written with the correct number of sig figs. I believe there's a problem. Yeah, number 1, they ask you how many sig figs are in each number, but problem 5 is about evaluating. So we actually got to do the math for that one. Totally. You can totally see an example. Were you asking specifically about part 5 from the worksheet, or was it for something else? Okay, solid. Yeah, here. Honestly, number 5 is totally is a little bit on the tricky side. So here's an example that's similar to. I'm gonna change the numbers, but it's similar to 5A. Okay, so let's see. Let's go 44.3 plus 9 plus. No, I'm not going to do another 4. Let's do 17.2. All right, so this is an addition problem. And I'm actually, let's see, do we ask? No, we don't have to do scientific notation. We do have to do the correct number of sig figs. So I'm actually going to rearrange this because I think it's a little easier to visualize if I stack this situation. All right. So first step when you're doing any math problem is to do the actual. I need to turn the light on here. Is to do the actual math, right? We need to do the addition, and the beauty of Chem class is we don't have to do this kind of stuff in our heads. Excuse me, we can totally do use a calculator for this. So 44.3 plus 9 plus 17.2. You do this addition, this comes out to be 70.5, and that is the correct value, but it does not necessarily have the correct number of sig figs. The rules, in my experience, the rules for adding and subtracting significant figures tends to be more challenging for students than multiplication and division. Because when you're adding and subtracting, you need to look at the last significant digit in every number. You need to look at the precision. All right, and so 44.3 has its last significant digit in the first decimal place. 9 has its last significant digit in the ones place. And 17.2 has its last significant digit again, in the first decimal place. Now, what we've just done by identifying the last significant digit in the number, that is the precision of each number. And the answer needs to have the same precision as the least precise number we used in the addition. Now, $44.3 and $17.2 have the same precision. Because their last significant digit is in the same place. All right, it has the same place value. 9 is less precise. The more precise your number is, the further to the right the sig fig is going to be. The further to the left your last significant digit is, the less precise you are. So 9 is less precise, which means our answer must have the same precision as the number 9, which means its last significant digit has to be in the ones place. That means we need to round to the ones place. 5 rounds up, so the correct answer, rounded to the correct number of sig figs, is going to be 71. Again, with its last significant digit in the ones place. Okay. All right. Let me know if that one makes sense. I'm going to move to, Kimberly was wondering if I could explain question 3, which the wording of question 3 is a little bit different. So question 3 asks you, it says, round the number, and I'm going to make up a different number, but they have their number there. Round the number, I'm going to say, round the number 3,904.92 to, and then it blanks off. And there's problem A. It says round it to, 1 sig fig. B says 2 sig figs. Etc. D, A, B, or C, and D. We've got 3 sig figs, and D is 4 sig figs. All right, so for A, if we round this to 1 sig fig, we have to count 1 sig fig, and then ask, actually, hang on, here we go. 1 sig fig, 9 rounds up. So A rounded to 1 sig fig is 4,000, right? Because that first digit will be the only significant figure in the number if it has 1 sig fig. If we round it to with B to 2 sig figs. I'm going to switch up my colors here. We count off our first 2. 0 rounds down. So this would be 3,900. You'll notice all the place values are the same. But this has 2 sig figs. Let's round it to 3 sig figs. We count off 1, 2, 3. 4 rounds down, now we have a problem here. Because if we write 3,900, this only has 2 sig figs. In order to write, now, but 4 rounds down. So when we're rounding to 3 sig figs, it rounds to 3,900, but 3,900 only has 2. We need to write this in scientific notation in order to give it 3 sig figs. So this will be 3.90 times 10 to the third, right? 1, 2, 3. And we moved it to the left, so it's positive. All right, and then finally, oops, didn't mean to do that, excuse me. Let's take a look at number 4. If we have 4 sig figs, we count off 1, 2, 3, 4. This 9 rounds up. So rounded to 4 sig figs, this would be 3,904. All right. All right, let's see. All right, let's see. Okay, so Kaylee, when trying to find out how many sig figs in a problem with multiple trying to figure out how many sig figs in a problem with multiple operations is confusing me when the problem, for example, has both addition and multiplication. I get stuck. Kaylee, you are not alone. That is honestly the most challenging type of significant digit problem out there. So let's get in this. Mixed operations. Okay, here. Sorry, before we dive in there, let me answer Gabriella's problem while this thing is still live. All right. Okay. Okay. Oh, okay. That's the, yep. Okay, so let's do this. Rounding to 3 sig figs. But let's really zero in. Apologize for the screen clutter. It's only momentary. All right. Let's really dig into this. So 3 sig figs. If you're going to round to 3 sig figs, you got to count them off, right? 1, 2, 3. And then you have to ask, does 4 round up or down? And the answer is 4 rounds down, right? So 4 is not going to turn this 0 into a 1. It's going to leave it as a 0. Let's look at the value. Let's look at the number we get when we round 4 down. The number we get is 3,900. Let's ask a new question. How many sig figs how many sig figs are in the number 3,900? And the answer is 2. Right, there are 2 sig figs in that number, but we're trying to round it to 3. So the challenge we now have is, how do you write the number 3,900 with 3 significant digits? And the answer is with scientific notation. All right? The only way to write 3,900, which naturally has 2 sig figs, with 3 significant figures, is using scientific notation. All right, here's how. First, we know that we need to place our decimal after our first non-zero digit. Right now the decimal is right here, so we roll it over 1, 2, 3 spaces. So this is going to be 3.9 times 10 to the third. We know that it's to the third because we moved it over 3 spaces. Every space is 1 exponent, 1 power of 10. We know it's positive because we moved our decimal place to the right. Sorry, to the left. Dyslexia is fun. Now, 3.9 has 2 sig figs. 3.90 has 1, 2, 3 sig figs. So that is how you round your original number to 3 significant digits, and how you write it, how you express it with 3 significant digits. It has to be, for this number, has to be with scientific notation. Okay. Other questions up in the chat? Oh, okay. Thank you all for catching it. Rounded to 4 sig figs is 100%. Oops. A 5. 3,905. Sorry, that is my bad. Okay, sorry. Okay, I knew there was a question that I needed to answer. Kaylee, you had a question on mixed operations. Okay. So let's talk about mixed operations. So we know that there are rules for addition and subtraction with sig figs. We know there are rules for multiplication and division. What happens when you're doing both? Right? So what happens if you are given a situation like this? (12 plus 9 divided by 3.68). This is where things get tricky. Because you're like, well, I would know what to do if I just said addition. I would know what to do if I just said division. What happens when they're all mixed together? And the answer is you have to use all the rules for sig figs. And you have to apply them in order of occurrence for the operations themselves. So order of operations says numerator first. We're going to add, then divide. All right, so that means step 1, you go 12 plus 9. 12 plus 9 is 21. And now you have to ask yourself, how many sig figs should I have? The last significant digit in 12 is in the ones place. The last significant digit for 9 is in the ones place. So 21 must have its last significant digit in the ones place, and it does. Sorry, my hair's shaking loose. So this has its last significant digit in the ones place, so we do not need to round or do anything to our numerator. So now we have 21 divided by 3.68. All right, I can't do this one in my head, so I'm going to bust out my calculator. 21 divided by 3.68 is 5.7065217391. Now sig figs. Our numerator has 2 significant digits. Our denominator has 3, when you divide, your answer must have the same number of significant digits as the number you used, with fewer. 21 only has 2 significant digits, so my answer can only have 2. 0 rounds down, so my answer is 5.7. So that is how you handle mixed operation scenarios. You go order of operations, add, then apply the rules for adding and subtracting, then divide, and apply the rules for division and multiplication. All right, let's see. 7F. All right. Okay, yeah. Okay. Let's take, so this one is a monster. All right. Oh, all right, all right. Brutal. So we've got a numerator. Go. All right, so we've got a numerator. Let's go 9.44 times 10 to the negative 1 minus 13.7 times 10 to the negative 3 divided by 5.26 times 10 to the negative 2 times 4.3 times 10 to the negative 1. All right, so we got numerators, denominators, multiplication, subtraction, the whole bit. Okay. Quite a challenge. So, let's... All right. So real quick, got a question. Got a question from Discord about filling out the thing. Someone who's filling it out digitally, typing in. They were asking about showing work, and for these exercises, you do not need to show your work. I'll be grading them based on the answer. I'll be grading the answers based on whether they are correct or incorrect. So if you're typing in digitally, you don't have to show your work. If you're filling it out physically, you also don't have to show your work. It's just going to be graded as right or wrong. If you had the same question, now you know. Okay, so let's evaluate this. Now, here's, when I look at this problem, this is the critical divide that I see. I see this right here. All right. To me, when I see that numerator-denominator situation, when I look at the numerator, I think step 1. When I see the denominator, I think step 2. All right. So here's how I'm going to tackle this problem. I'm going to solve the numerator first. Figure out what the numerator's worth. Then I'm going to pause, do the same thing for the denominator. Once I know what the numerator is simplified and the denominator is simplified, I'm going to bring them back together, and solve the situation. So that is the approach that I am taking. So let's start. Whoa, sorry, I didn't mean to blank everything out. Or maybe I did. Let's go ahead and start with step 1. Oops. So step 1. All right. So going for our numerator. Our numerator is 9.44 times 10 to the negative 1 minus 13.7 times 10 to the negative third. All right. Now, honestly, whenever you're adding or subtracting numbers that are in scientific notation, it can be very, very difficult to evaluate those. I always convert them from scientific notation to standard notation if I'm going to evaluate them. So let's turn these from scientific notation into standard. 9.44 times 10 to the negative 1 equals, so this negative 1 means we need to move the decimal over one space to the left. That's what that means. So this would be 0.944. Let's look at 13.7 times 10 to the negative 3. That negative 3 means we need to roll this decimal place over 1, 2, 3 spaces. So we're going to have to add a 0 right there. This is equal to 0.0137. Now we take these two. Well, we need to do a subtraction, right? We do this number minus, this number minus this number. So 0.944 minus 0.0137 is 0.9303. So that's what my calculator is telling me. Now we have to apply the rules for Sig Figs. When you look at the precision of these two numbers, 0.944 has its last significant digit in the third decimal place. 0.0137 has its last significant digit in the fourth decimal place. Our precision has to reflect our least precise number, so its last significant digit needs to be in the third decimal place. So this number, has 3 decimal places. Now, I'm not going to round this number right now because we should save our rounding for the very last step. But I'm going to put these 3 lines here to remind myself that this value has 3 significant digits. So let's roll things back and rewrite our numerator as, I've already forgotten, there we go. Point 93, there we go, 03, but we only have 3 significant digits in our numerator. That is step number 1. Let's take a look at step 2. Let's figure out our denominator, and then we'll bring this whole thing back home. So our denominator is 5.26 times 10 to the negative 2 times 4.3 times 10 to the negative 1. Again, everything in this expression is multiplied. So we can rearrange this however we want. So we can rewrite this as 5.26 times 4.3 times 10 to the negative 2 times 10 to the negative 1. Now, when you go 5.26 times 4.3, that comes out to be 22.618. Now, when you look at your sig figs here, 5.26 has 3, 4.3 only has 2. We can only have 2 sig figs. So I'm going to put, again, waiting to round till the end. I'm putting 2 lines here to remind myself that this number is 2 sig figs, but I'm going to leave the whole thing unrounded in there. Now, 10 to the negative 2 times 10 to the negative 1, we just add our exponents. That's negative 2 minus 1. So this comes out to be 22.618 times 10 to the negative 3, and this number has 3 sig figs. To put this in the denominator, it's going to be easier to evaluate if this is not in scientific notation. So I'm going to go ahead and cash that in now. That negative 3 means I need to roll my decimal place 1, 2, 3 spaces over. So this is equal to 0.022618. And again, keeping 2 sig figs. I'm putting those lines to remind myself. That is the denominator. Oops, not there. Denominator I am looking for. So this is let's go down here. 0.022618. And I have 2 sig figs down here. So now I'm ready to divide my numerator by my denominator. 0.9303 divided by 0.022618. My calculator is telling me that the answer is 41.1309576. And I've got 2 significant figures in my denominator, 3 in my numerator. I've got to roll with the smaller amount of sig figs. So I count off my first 2. 1 rounds down. So my final answer is 41. For this problem, which is similar to question F. Okay. Let's say we have a request for something similar to 5D. Yeah, let's give this weirdo a try. All right. Let's see. 5D. Okay, so let's go with 437.1 minus 1.7 times 10 to the third. Okay, here's the deal. Anytime someone asks you to add or subtract a number where you've got standard mixed with scientific, all right, anytime you see that, where you add or subtract numbers that are given to you, one's in standard notation, one's in scientific notation, you should think one thing and one thing only. It's a trap. They're trying to get you to do 437.1 minus 1.7, and you'll be dead wrong every time. If you're going to add or subtract numbers, convert all of them to standard notation, then do the addition. If one's in scientific notation, whoever wrote the problem is trying to fool you, but now you're smarter than them, and you're not going to fall for it. So let's do that. Let's convert this to standard notation. 1.7 times 10 to the 3. Well, because it's 10 to the positive 3, that means I need to take my decimal and roll it 1, 2, 3 spaces over. Actually, let me write this. So 1.7 times 10 to the third means I'm going to take this decimal and roll it 1, 2, 3 spaces over. That means I need to add 2 zeros in here. So 1.7 times 10 to the third equals 1,700. 1,700 minus 437 is much different than 437 minus 1.7. So let's write this out. 437.1 minus 1,700. Again, busting out the calculator. My calculator is telling me that my answer, the value, is negative 1,602 or 1,262.9. But now we have to look at Sig Figs. 437.1 has its last significant digit in the first decimal place. 1,700 has its last significant digit in the hundreds place. That means we got to round our answer to the least precise, which is 1700. So we got to round to the hundreds place. 6 rounds up. So our final answer will be negative 1300. All right. Okay, let's see. Okay, we have another question about. Oh wait, let me. Okay. Oh, okay. Gabrielle has a question on something I did a couple of problems back. Oops. Okay. All right, Gabriella. Oh, okay. Actually, before I shift to Gabriella, since Viri's question is about the one that we have live. Okay, so let's do this. Oh, hang on. There we go. So let's break this problem down just a little bit. So here, to evaluate this problem, to answer this question, here are the steps. First, convert all scientific notation to standard notation. That's step 1. Step 2 is add and apply rules for Sig Figs. All right, so this is the 2-step process. First, before we do any addition, we have to convert any number in scientific notation to standard notation. Then we're going to add. Now, there's only one number in scientific notation, and that is 1.7 times 10 to the third. All right, so 1.7 times 10 to the third. Now, the way you convert from scientific notation to standard notation is we're going to have to move the decimal. This power of 3 tells us that this decimal place was moved 3 spaces over to the right when it was taken from standard to scientific. So to convert it back to standard notation, we need to take, it was moved 3 spaces to the left. To convert it back to standard, we need to take this decimal and move it 1, 2, 3 spaces to the right. So the decimal goes right here. But the thing is, you can't have nothing in between 7 and that decimal. So in each spot, a 0 goes. All right, so 1.7 times 10 to the third is equal to 1,700. And if you don't believe me, punch in 1.7 times 10 to the third into your calculator. 1,700 is the answer that comes out. So that is step 1 of this problem. So now we have 437.1 minus 1,700. When you punch this into your calculator, because I can't do this math in my head. Well, I guess I could do it in my head, but it'd be slow and cumbersome. So I'm going to go 437.1 minus 1,700. This comes out to be negative 1,262.9. When I look at the significant digits for each, 437.1 has its last significant digit in the first decimal place. 1,700 has its last significant digit in the hundreds place, making it less precise, meaning that we have to round our answer to the hundreds place. 6 rounds up and is going to turn this 2 into a 3, so our answer is negative 1,300 even. Okay, Gabriella, thank you for being patient. Let's roll into your problem, or your question. So let's see. So question before, the question that Gabriella has is, I added 12 plus 9, and she's asking why was it only 1 sig fig instead of 2? Do not apologize. Great question. It does have 2 sig figs. So when you add them together, the answer is 21. And you'll recall what I did is I said, okay, where's 12's last significant digit? It's in the ones place. 9's last significant digit is in the ones place. And I said, so that means our answer must have its last significant digit in the ones place, and 21 does. 21 totally has 2 sig figs. But the reason why I was only underlining one thing was because we weren't assessing how many total sig figs it has, because we're adding. We just are assessing how precise it is. And 12 is precise to the ones place, 9 is precise to the ones place. So what matters here is that our last significant digit is in the ones place. But there are 2 significant digits total. Let me know if that makes sense. I know I only drew one line, I think, in the previous one because I was just looking at the place value of the last significant digit in the number, but it does have 2 total sig figs. I just wasn't focusing on the total number because you only focus on the total number when you multiply and divide. Oh, let's see here. Sorry, we got a couple questions in the chat. I was doing some stuff on Discord. Okay. Okay, here, hang on. We've got a couple questions here. All right, so this one's coming from Discord. And this is similar to 6b. All right, so this problem is similar to 6b. Let me find it again. Yeah, so if you have a situation like 7.75 times 10 to the 22 divided by 9.08 times 10 to the 16. How do you handle this? Well, we know that, oh, yep, this actually hits the question on Discord plus the two in the live chat. So we can rewrite this, right, as 7.75 times 10 to the 22nd over 9.08 times 10 to the 16th, right? And you can also break this up further to kind of simplify it and kind of split things down the middle here. We can write this as these two are equal to 7.75 over 9.08 times 10 to the 22 over 10 to the 16. This is just easier to handle. So we can evaluate the first of these two fractions, 7.75 divided by 9.08. This is 0.853524229. That's this division. We can only keep 3 sig figs because our numerator and denominator only have 3. I'm going to round that in a minute. And now when you look at 10 to the 22nd divided by 10 to the 16, that is literally equal to 10 to the 22nd minus 16, right? When you multiply 10 to the power of whatever times another 10 with an exponent, you add those exponents, so when you divide, you totally subtract, just like you were asking, Loretta. So when I round this to 3 sig figs, this 5 rounds up. So this would be 0.854 times 10. 22 minus 16 is 6. Now, something to watch out for. If you look at problem number 6, it said, perform each calculation, report your answers in proper scientific notation with the correct number of sig figs. And this right here, though it is the correct answer, is not scientific notation. It's not scientific notation because scientific notation means that our decimal must be behind our first non-zero digit, and this decimal is right here. So we actually need to roll this over 1. And so our final answer is going to be So again, here I'm just going to rewrite this 0.854 times 10 to the 6th. We need to roll this over by one space. So this is going to be 8.54. When you roll it one space over to the right, you subtract 1. So 8.54 times 10 to the 5th. That is the correct value with the correct number of sig figs expressed in scientific notation. So Kylie, I will totally do something similar to 7D. In just one second, I've got a question on Discord that came in first, and then I'll hit yours. Okay, let me. Okay. Sorry. Okay. Okay. All right, Kaylee, you wanted to see an example like 7D. All right. Let's do something. Something similar. All right. So let's do something like 7D. Let's go ahead and do. All right. All right. So this is a lot of stuff going on. But the way you want to break this down is into 2 steps. All right? And here's where you find that divide. Whoops. The way you break this down is by taking the fraction and your numerator, evaluating your numerator is step 1. So just figure out the numerator in isolation of the denominator. That's step 1. Second step, figure out what the denominator is equal to, evaluate the denominator, and then bring them both back together and evaluate this thing as a whole. All right, so we're going to handle step 1 first. All right, so this is 1.43 times 10 to the negative 2 minus 1.2 times 10 to the negative 1. Now, anytime you're doing addition and subtraction, I said this earlier, anytime you see addition or subtraction and numbers are in scientific notation, whoever wrote the problem is trying to fool you. All right, it's a trap. You got to convert them to standard notation first and then do the addition or subtraction. All right, so 1.43 times 10 to the negative 2. All right, this negative 2 means we need to take our decimal and roll it 2 spaces this way. All right, so this is equal to 0.1 or 0.0143. Let's do the same thing with 1.2 times 10 to the negative 1. All right, here we got to take this decimal place and roll it over by 1 space. So this is equal to 0.12. All right, now that we've converted these into standard notation, we can do the subtraction, right? We can do 0.0143 minus 0.12. Let's punch this into our calculators. Point 0.0143 minus 0.12 is negative 0.1057. Now, when you look at your Sig Figs, the numerator has its last significant digit in the 4th decimal place. Or sorry, not the numerator, the first number. Second number has its last significant digit in the 2nd decimal place. That has to be the last decimal place in this number. So this number will have 2 significant digits. That is step 1. That is our numerator. All right, so our numerator is there we go. So our numerator is equal to, our numerator is negative 0.1057. And there are 2 sig figs there. Now we need to determine our denominator, and that is step 2. All right, we got to evaluate that denominator. So we have 4.91 times 10 to the negative 3rd times 3.74 times 10 to the negative 1, right? Yeah, okay, just making sure. Now, because everything here is multiplied, we can multiply this in any order. And I find it easiest to group our numbers together and our exponents of 10 together. All right. 4.91 times 3.74 comes out to be 18.3634. We can only have 3 sig figs from this multiplication, so I'm going to put 3 lines to remind myself that we got 3 sig figs there, times, now if we have 10 to the negative 3 times 10 to the negative 1, we just got to add this. This is 10 to the negative 3 minus 1. All right, so this is 18.3634 times 10 to the negative 4. And there are 3 sig figs in this number. It's going to be easiest to evaluate our numerator over denominator if we have everything in standard notation. So let's go ahead and multiply this by 10 to the negative 4. Comes out to be, let's see, 1, 2, 3, 4. So the decimal goes here. We got a couple zeros ahead of it. And this has 3 sig figs. All right, that is step 2. Let's go ahead and take this back. Point 0.00183634. All right, now we can evaluate. We got 0.1057. Oh, sorry. Before we go, we got 3 sig figs in our denominator. Divided by 0.00183634. Is equal to 57.5601468.138. We're limited to 2 sig figs because of our numerator, and 5 rounds up. So our final answer would be 58. Alrighty. Abigail, great question. Yeah. So Abigail, the way will be graded is I will grade all the questions, the answers that you give is either right or wrong, and then the percentage of questions you get correct versus the total. That's the percentage of the 3 points that this assignment is worth that you'll score. Destiny, I totally can. Um, which lecture were you watching so I can look it up? Okay, awesome. Let me check. Thanks for letting me know which lecture it was in. All right, let's see here. Okay, so let's see the challenge problem. So Destiny, if it, I actually don't have an answer key off the top of my head. So to answer your question, I'm gonna actually need to do it myself. I just wanted to let you know in case you're like, why is he taking so long? Why doesn't he just tell me right or wrong? Because I don't know off the top of my head. But here's challenge question from lecture 4. All right, so we're supposed to determine the number of water molecules contained in 500.0 milliliters of water. And the first step, we're given the density, and it's to use the density to convert from from milliliters of water to grams of water. So milliliters of water cancels. Second step, we need to convert from grams of water to moles of water. And we actually need to calculate the molecular weight of water. So hydrogen has an atomic mass of 1.008. Oxygen has an atomic mass of 16.00. But there are 2 hydrogen molecules in water, so we got to multiply 1.008 by 2. And when we do, we get 18.016. This calculated number, if we're looking at Sig Figs, needs to have its last significant digit in the second decimal place, because based on the numbers that I use, you might be using a periodic table which has a greater precision, which is totally fine. All right, and this will cancel grams of water. So now we have moles of water. Our final conversion is to convert from moles to molecules. And 1 mole of water has 6.022 times 10 to the 23rd molecules of water. Moles of water cancel. All right, so this is 500 times 1.008 divided by 18.016 times 6.022 times 10 to the negative 23rd. So my calculator is telling me that my answer is 1.68466 25221 times 10 to the 25th. Now, Sig Figs wise, let's take a look. So our volume has 4. This density has 4. Our molecular weight has 4. Avogadro's number has 4. So we're limited to 1, 2, 3, 4. This 6 is going to round up. So this would be 1.685 times 10 to the 25th molecules of water. Okay, so Destiny, your value is correct, but the your sig figs are off. There needs to be one more sig fig based on the numbers given in this problem. Okay, Virginia, let's see. When a negative and negative exponent is multiplied, does it stay negative? Okay, yes, yeah. So. Okay, so let's. So whenever you multiply, for example, 10 to the power of x, or let's say the x is 10 to the power of a times 10 to the power of b, that is equal to 10 to the a plus b. All right, so if a is 2 and b is 4, that would mean that this is 10 to the 10 to the 2 plus 4. If a was negative 1 and b was negative 3, that means it would be 10 to the negative 1 minus 3, which is 10 to the negative 4. So because we're adding, if both exponents of 10 are negative, they will totally stay negative. Okay, let's see. So we just had a burst of questions all of a sudden. Okay. And we have... Sorry, we got some stuff going on in Discord. Okay, so... Okay, so real quick, a question porting over from Discord. So if you have a number like 10,179.76, how do you round this to 2 sig figs? Well, you have to count off the first 2 spaces, right? So 1, 2. This is where we're going to round. 1 rounds down. So once you round, this would be 10, 0, 10,000. Because the 1 space gets a 0, the 7 space gets a 0, and the 100 space gets a 0 after rounding. There's only one problem. 10,000, excuse me, getting all choked up. 10,000 only has 1 sig fig. And we were told to round to 2 sig figs. The only way to write 10,000 with 2 sig figs is using scientific notation. So first, we're going to convert this to scientific notation, taking our decimal and rolling it over 1, 2, 3, 4. Because we've got to place our decimal after our first non-zero digit. So this will be 1 times 10 to the 4th. Again, it's 10 to the 4th because we had to bounce our decimal place over 1, 2, 3, 4 spaces. Now 1 only has 1 sig fig. And that's why we're going to add a 0.0. Now we have 2 sig figs. So that is how you round a number like 10,179.76 to 2 sig figs. For this one, we have to use scientific notation because after rounding, our value only has 1 sig fig in it. Scientific notation will bail you out every time. Okay, let's see. Okay, Kimberly. Oh. Cool. I actually just answered your question too. It was asked simultaneously on Discord. All right, cool. So we're good there. All right, and Samantha, you want to see a problem similar to 7C. Let me pull that up. All right. Let's rock and roll. Okay. 7C. Oh, cool. Okay, let's see. 7 part C. All right, so let's evaluate 4.9 times 3.33 times 18.2 over 48.0 times 0.0056 times 22. All right. So here's, okay. Because this is all multiplication and division, you can actually punch this entire thing into your calculator. If you do, after you hit the divided sign, you have to throw this entire thing in parentheses. All right, that's just one thing to be aware of if you're punching this into your calculator all at once. I'm going to evaluate the numerator and then the denominator, and then we'll move from there. So numerator is 4.9 times 3.33 times 18.2. 296.9694. Sig Figs wise, we're limited to 2 sig figs in our numerator, so I'm going to wait around to the end, but I'm putting those 2 lines there to remind myself that my numerator has 2 significant figures. Let's evaluate the denominator. 48 times 0.0056 times 22 comes out to be 5.9136, and my denominator can have 2 sig figs because of 22. Now we do numerator over to denominator. 296.9694 divided by 5.9136. $50.21803977727 is the value. After I round this to 2 sig figs, there's going to be a good chance to practice our scientific notation. 2 rounds down, so after I round this, I just get 50. The problem is 50 only has 1 significant digit. So to write this with 2 significant digits, we need to use scientific notation. Our decimal is right here. We're bouncing it over 1 space, so this will be 5.0 times 10 to the first. Again, 2 sig figs. Whereas 50 only has 1. All right, I will be, I'm gonna step away for just a minute. I need to go use the restroom, but I'll be back in just a second here. Alrighty, well that is gonna do it for lab tonight. Thanks for everybody who came out and honestly made it an awesome lab section. I'll catch you all next time.